Okay, so in the last lecture, we understood about what is the log loss. Now we have a bigger problem here. Problem is that let's say if I have a metric of accuracy. Now in accuracy, we know that my accuracy, if it is like uh, can be between 0 to 1, and in 0 to 1 case, if more closer to 1 is good, right? So it means that if it is, let's say, 0.90, then we say that we have a 90% accuracy in this case. So it is closer to 1, it's good to this. Similarly, we do have AUC, area under curve, and this value also, if it is closer to 1, it's good. Now, we do have a lot of metrics where we do have a defined criteria. If it is falling in this, it's good, or if it's not coming to this is bad. But if you look at the log loss, in log loss, the value can go from 0 to infinity. Now, the thing is that, yeah, I know that if the value comes out to be somehow 0, it's a best model, right? It's a best model. There's no doubt about it. But the problem is that we do not generally get as a best model, right? Maybe let's say if in some model I use and I got the value of 1.5. Now, what I can really say from this number? Can I say that the model is good or bad? How can I really do some comparison? Because the highest value can go to infinity here, right? So there should be some kind of comparison metric to it. That's the reason log loss is not that good in visualizing and giving it the output. So now in our problem statement, since we have to use log loss, so how we should really go about it, how we should really think about using this log loss matrix and say that, okay, this is the good model or bad model. Now, one way, there can be various methods. I'm going to tell you one method. One way is, how about if we generate a random model? When I say random model, I'm talking about a model which is the worst model possible. Okay, this is the worst model, which will be you, which we will create by completely by some random numbers. And that model is, for that model which we're gonna generate on our data set, we gonna basically compute the log loss. Okay, let's say that log loss come out to be 3. Let's say that log out comes out to be 3. Then after that, what we will do, we will start generating our models. Okay, let's say we will generate a LR model, okay, which is logistic regression model. If this LR model is going to return me, let's say, log loss of, let's say, 1, right, or 1.5, in that case, if I compare with 1.5 with 3, definitely LR model is performing better than my random model. That means this model is better in comparison to any worst model which we have. So this is the strategy which we're gonna take in order to deal with this log loss. And maybe we will compare this basically log loss for various algorithms, and we will see that which algorithm is going to give me the minimum log loss, because that would be our main focus here. Now, in order to do that, how we should generate a random model? Now, here we are working with probabilities, right? So, in terms of probabilities, if we look at, definitely all the probabilities of, let's say, 1, 2, 3 till ninth model, if sorry, the ninth model. So, here the sum of these probabilities should be equivalent to 1. So the way I will generate this model is, random model would be that in the end, the final probabilities which I will randomly generate is the sum of those probabilities should be equivalent to 1. That's something which we have to keep in mind while creating it. So let's go and see how we can work out on this sort of models. So first of all, we need to work on all the probabilities for my test data set and my cross validation. So we are taking the length for it, because for each row we gonna generate this probability, right? For first row we gonna generate the probability for all these 9 classes. For second row also we gonna do the same, and similar thing we gonna do till nth row. So that's the reason we got for this, because we want to generate the log loss for my cross validation data set as well as for my testing data set. So that is something we gonna do now. Now, first what we did, we kept everything, because we need for all the 9 values, right? So we need to fill up basically 9 values here, 1, 2, 3, 4 till 9. So that's the reason initially we took all the values to 0, all the 9 values to 0, and later we're gonna fill it with some more appropriate values. Now, in order to do that, what we're gonna do, we're gonna run it for my whole cross-validation dataset, and we're gonna do the same thing for testing later. First, we started with cross-validation dataset, and we started putting the value randomly. Now you may say that, okay, randomly this may not sum up to 1. That we will do in the next step. So we put the value randomly. And in the next step, to make the sum value basically equivalent to the part, what we did, we basically divided it with the sum of all those part. And this is gonna ensure that the sum of the probability should be equivalent to 1, right? So that's what we're gonna get. Now after this, once we got this part, we have to calculate now the log loss for this cross validation in the random model. So what we will do, there is a function called as log underscore loss for calculating all this for us. And here we're gonna pass our actual output, which is for cross validation, and my predicted part, which we just computed here, which is random probabilities, which we have just put in, so that the sum of all these probabilities should be equivalent to 1. And once we pass this, we got the log loss to be 2.49 for cross validation. Now what does this tells us? This tells us that 2.49 is the worst log loss, and if any of my model which I'm gonna generate is gonna be greater than this, that means it's a worst model, means even it worse than worst model, and we should not consider that. So we got some sort of criteria now that all the models we gonna generate should have lesser than 2.49 cross validation log loss error. Let's do the same thing for my basically for my test also. You can see that we are taking exactly the same route for this. We took all the 9 values to 0 initially, then we took the run it for all the test data rows, and we put randomly 9 values, and we made sure that all the values should sum up to 1 probability values, and we are passing my y-test original value and the predicted, which we have just done it randomly, and we got the log loss of 2.48. So for the random data model, for my test set and the cross validation set, we are getting the log loss of 2.48 and 2.49, which is quite close. So this is how we got this part. Now this is basically for the random model, right? So we do want to do some more analysis on this. So what we gonna do is, we definitely, if you look at it, let's say if my random model is returning this sort of output, let's say 0 0.1, 0 0.1, 0 0.05, 0 0.05, and so on, in such a way that then the last probability is 0.2, right? So let's say this is my output, and all this sum of 9 values is equivalent to 1 somehow. Now in this case, let's say if 0.02 is the highest value, so this should return, right? This should get returned that when class 9 is having the highest probability, so it should return it. So that's what we are doing with the argmax. So we are going to now get the index at which it is highest. So you can see that we gonna get it in my predicted underscore y, and these are all the indexes, but you can notice that it have taken the index from 0 to basically values 0 to 8. So we have to increase it to bring it to the scale of 1 to 9. Let's add it plus 1 to it so that we can bring it to the same scale in which we are solving our algorithm. So this is the way we have generated our random model. We got our log loss for it, and now we gonna work further on it on the same random model to look at various metrics, because once we get this, we definitely want to ensure that how my confusion matrix looks like, how my precision matrix looks like, how my recall matrix looks like. So this we will do all those things in the next lecture.